The CSV file is in this format: country, city name, region, population, latitude, and longitude, and return a hash map of all of that data by country. So mapping each country name, or country code in this case, they're 2-digit country codes, to all of the cities of that country in an array list. This is what we want to return in this method. So we want to parse this file that we're given and get it in this hash map, read all the data and stuff it in this hash map and return that hash map. And we have a file, the cities.csv. It does have a header line, and then it has enough data to lag my computer a little bit there. And a lot of data, lots and lots and lots of cities in here. What do I mean by lots and lots? Well, 47,977. We have the header line, so not quite the 78. But about 48,000 cities. So a lot of data here. And something I really haven't mentioned yet, hopefully they hit on this in 115 at least a little bit. They might not, though. But, like, why do we even write code? Why do we even have computers at all? This is one of the reasons why. Computers are bad at a lot of things. Like, we really have to tell it step by step exactly what to do. The computer can't think, it can't figure things out, it can't fix our errors for us. They're really dumb machines. But there's 3 things they can do extremely well. 1, they're fast. They're ridiculously fast. 2, they're accurate. They're always going to, I shouldn't say always, but almost always going to get the right answer. They're going to do the right thing. They're not going to make human error. They're not going to have human error. They're not going to have little mistakes constantly. The processor, you give it 2 numbers to crunch, it's going to crunch them in the right way, whether you're adding, bit shifting, XORing, whatever you're asking it to do. And 3, it has perfect memory. It will remember whatever we have, you know, aside from like solar flares and hammers and stuff. The hard drive and memory, they're going to remember everything that it's supposed to, every single bit of data. It's going to remember it the right way. And those are 3 things that us as humans are very bad at. So machines can really complement us well because we're good at the thinking, pattern recognition, and things that AI still have trouble doing, we can do very well. And the computer can do the speed, accuracy, and memory very well. So those are the things we want it to focus on. When we have a data file like this, where we have a lot of data, and the songs data, the movie data, any data like this, where we have a lot of it, so much that we can't wrap our heads around it. Like, I'm never, ever going through this whole file, which is, by the way, a fairly small file. Like, there are much larger data sets out there. I'm never going through all of this data, ever. Not even going to look at it all, much less actually process this. If I have some lat long where I'm, for some reason, like stranded in a desert somewhere, but I have GPS and it's telling me my latitude and longitude, but without like a map, not a whole app built to it, but with it, and I have this data set. I can compute the closest city to me, and actually in that situation, I got time, I might do it anyway. I might actually do it, bless you. But I don't want to go through all of this data and figure it out. I'd rather write some code and have the computer do it, because the computer can find the closest city to a specific lat long in a matter of milliseconds. It'll probably take longer for the code to compile than it will to actually run and calculate the value that I want out of all this data. Because this is what computers are really made for. This is what they excel at, is crunching the numbers. And that's really why these are such useful tools. When we have a lot of data, it can go through it very, very quickly. And of course, because of the internet, but that's a whole separate conversation. So we want to process this data. We're given a file name. We know it's in that format, but we don't know what data it's going to actually contain. So let's write some code and handle that data. And let's set this up. So first, I'm going to start with cut and pasting because I don't feel like typing this whole thing again. We're going to create our hash map. The first thing I'm going to do here is create the hash map that I'm going to return. I'm going to name it countries. And that's what's going to be returned. So we got the first line and the last line of our method done. It's everything in the middle that we have to work on to process this file, read the file, get all the information into this data structure that we're going to return. And for this, I'm going to do things a little bit differently. Actually, I didn't do it the first way in this lecture. Let me do it differently than I did in the last lecture then. It'll actually be more like the slides, I suppose. I want to read the file. I'm going to do that in an array list because I want to work with my array list of lines equals files dot read all lines paths dot get path, or paths dot get file name. So this is right from the slides. We're going to read the lines of the file. I need to slap that in an array list. And this is going to give me an error. You're going to get the error right here that we expect. Unhandled exception, IO exception. So this code is dangerous. It can throw an exception, and it can throw an exception that we cannot predict. So Java is going to say, you have to handle this exception because you can't have any way of predicting whether it's going to happen or not. You can check if the file exists, but that's not guaranteed. Another process can come in at the last second, the last millisecond, and delete that file on you. Like, things can go wrong here. So we have to wrap this in a try-catch block. So I'm going to try to run this code. And if it throws an IO exception, I'm going to catch that exception. I'm going to give it a real name here. In the slides, I just call it E. But let's call it exception as the variable name here and give it an actual meaningful name. And if the exception is thrown, I didn't put it in the description here, but we'll return an empty hash map. Now I could, this is a situation where it's more preference of what exactly to do here. I just initialized an empty hash map of countries, and that hash map is going to be returned. And if this file can't be opened, then I'm never adding anything to that hash map. So I don't really have to put anything here. I can have this be empty and just rely on returning countries, which is going to be empty at that time. It's going to be the same effect. Personally, I like having this right here to make sure that I'm explicit in my code. If somebody's reading this code, or if I'm reading this code 2 years from now, I can look at this and say, yes, if the file can't be read, I want, as my expected behavior, to return an empty hash map. If this line isn't here, it will return an empty hash map, but it's not entirely clear if that's what the developer intended, or if that's just the behavior they happened to get, and they forgot to code what should actually happen. So for my money, I like to have very explicit code, make it very clear that I want an empty hash map returned if the file doesn't exist, even though that line doesn't have to be there. All right, so we read the lines of the file. We're catching the exception in case the file doesn't exist. And then for each line in lines, I want to process this line. The first thing we're going to do is split it on commas. Not exactly what we should do with CSV text in general, but it's going to work for us in this class. I'm going to array list this, array list, string. So we're dealing with array list. If you want to work with plain arrays, that's fine. Knock yourself out. I'll use array lists in class just because that's what we've been dealing with all semester. And I always call this variable splits. I don't know, it's just something I picked up. New array list, arrays.asList, line.split on comma. That's going to give me my splits. So the juicy part of this is splitting on commas. That's going to return an array of all the comma-separated values. And then all this extra, this is me converting that into an array list. So we can work with an array list instead of an array. I would probably normally just use an array here, to be honest. But I want to use the array list just because, consistency with the rest of the course, where we've always used array list. And then we want to process this data finally. To process the data, whenever I have data in a very specific format that follows a specific format like this, what I like to do is go with Casper, Wyoming. I'm going to grab a sample line. And as I'm iterating over the lines, I'm going to paste it right here to use as a reference so I remember what the order of the values is. And sometimes when there is a header line like this, I'll grab the header line too. Just to help me remember, just so I absolutely know what each one of these values represents. Yeah.
Does each line have an index?
Have an index?
Yeah.
No. They have, so IntelliJ is giving me the line numbers, but there's no index per line. I mean, I guess they do in the array list, if that's what you mean. But I'm just looping over the array list. I'm not concerned about the indices. If you are, yeah, they do. And now when I'm ready to process this line, I'm going to refer to my reference line here, my reference data, and then get this in all of its values. So string country equals splits dot get 0. That's going to be at index 0 after the splits. Or did you mean after the splits? Each line technically will have an index because it's in an array list. The splits absolutely do, and we do need to be concerned about those ones. That's how we're going to get each piece of data. And again, for this course, you can assume that all the data has been sanitized, all the song data, all the movie data. It's going to be sanitized. The movie data is already sanitized. The song data should, but once we start getting reviews in the site, I like to go look through them and make sure somebody didn't maliciously upload garbage to it. It happens. Students do it. Where they'll try to write code that's going to break your parsing code, and then everybody has bugs. But I think I got rid of most of the things people like to do. But you can assume the data is sanitized, so we're going to assume every line has all of the values we expect, and the values are in the right format. So especially when we get to parsing the ints and parsing the doubles here, that you can just assume that it's going to be a well-formed integer or a well-formed double. So we get country, the city name, the region, population, latitude, longitude are all the values we want to extract from this, and we know their indices are going to be in that order. Just looking at my reference line to remember what the order is, getting everything in that order, that's going to give us all the values we want, but everything's going to be a string. When we call split, we're calling it on a string. We're getting an array list of strings. The line is an array list of strings. Everything's a string. This is a text file. There's no concept of a number in this file, in this format, until we assign it some value. So population, it is an int, but we're always going to get it as a string. These are doubles, but we're always going to get them as strings. So this is where we need to do our conversions. Integer dot parse int is going to convert the string into an integer if it can be. If it can't be, it's going to throw an exception, a malformed number exception. But if it can be, and we're going to assume everything's in the right format here, then it will convert that string into my numeric values, integers, or doubles, depending on what value I'm parsing at this point. And the population I'm going to parse as an int, because it's always going to be an int. Doesn't make sense to have a fraction of a person. But the latitude and longitude, those are going to be floating point values. So we're going to parse those as doubles. And at this point, we're ready to create a city. So when we create a city, I'm going to not make the mistake I made in the last lecture. When we create a city, we're going to refer to our city class, which is a reminder. Actually, I don't even know if I showed this, maybe very briefly yesterday, maybe not at all. Looks like not at all. But the city class is a pretty standard object, a pretty standard class. It's going to store the values that we want. It's going to initialize them all through a constructor, and I have getters for each one of those values, and a toString. I'm not going to really make use of that, though. And that's it. So we're going to use the constructor to set all the instance values, all the instance variables to the values, and use getters if we need to access those values. We have location for the lat long, and location, again, what you would expect. Two doubles, lat and long. Both of them are set through the constructor, and we have getters for both those values. What we need to pay attention to, and one of the things I see an issue with in the song class, which I still see issues with every once in a while, is making sure we get the right order of the parameters here. And actually, I shouldn't even say it like that because I just made the mistake last lecture. It's an easy mistake to make. But making sure we get the right order of our parameters. We have 3 strings. If we get these in the wrong order, we're not going to get any compiler errors. Same with the song class. If you call your song constructor and you give it those 3 strings in the wrong order, they're going to go to the wrong instance variables, but you're not going to see any error because they're all strings. All the types match. Everything's good with that. So we have to be careful with this one. Name, region, country, which I remember from last semester now that I purposely made this in a confusing order just to make this point, and then I forgot it last lecture. Oops. So name, city name, and I already forgot because I have the memory of a goldfish. Region, country. Name, region, country, population, and then a new location, lat, long. And that's our city. Let's store that in a variable. Get all the code on screen. Actually, I can just collapse this right now. And that's really the CSV part. Now we're on to, we're away from the file. We parsed the CSV. We already did everything with that. And now we have an object and a data structure. We need to get this object in the data structure. So this is the CSV parsing, file reading. All that's done for us now. And the next step is the trickier part. I don't know if it's fair to call this the trickier part. It can be pretty tricky, though. We need to get this city in this hash map. This hash map is going to store all of the cities for each country in its own array list. And that the key for that array list is going to be the country code for that country. This is made just in case it's not, some students don't always draw the connection and then they're like, lecture has nothing to do with the homework. I don't like getting that complaint. We get that in all of our courses in CS. Every lecture is designed to help you with the homework. But anyway, here's the connection. This is going to be when you're processing the song ratings file in homework 6. Songs can be rated multiple times. Each time a song is rated, it's going to be on a separate line. So your code has to identify, is this the first time I've seen this song? If it is, create a new song object and add that rating to that song object. If it's not the first time you've seen that song, you need to pull the existing song object for that song and then add that rating to the existing song. You want to make sure your code can handle multiple ratings of the same song. If you're not thinking of this, it's easy to have that song multiple times. If a song's rated 2 times, returning an array list with 2 objects for the same song, each one having one of those ratings. It's also common to have the new ratings overwrite the old song. Make sure you're not doing that. You need one song object with all the ratings. If a song's been rated 100 times, it's one song object with 100 ratings in its linked list of ratings. And then your testing should make sure that those songs have all the ratings that you expect. So that's what we want to do here. When we see a city, is this the first time we've seen the city? If so, we need to initialize our hash map and array list and initialize this country to say this is the first time we've seen it. If it's not the first time we've seen the country, we go to our hash map, get the array list for that country, and just add the city to the existing array list. So we have array lists instead of songs that contain linked lists, but it's the same idea here. We want to know 2 situations here. First time I've seen this country, or a subsequent time I've seen the country. Could be second, could be the 1000th. But is it the first time we've seen the country or not? So to do that, the check, we want to know if we've seen this country before. Have we seen this country before? We're going to say if countries, this has a convenient, hash map has a convenient contains key method. Contains key country. Then we've seen this country before. Else we haven't. Bless you. So we're going to check, have I seen this country before or not? I'm getting all kinds of warnings because Java's going to say, or IntelliJ is going to say, you've never added anything to this hash map. Of course it's not going to contain it. I'm pretty sure what the thing is. It's always false. Condition's always false because I never called the put method at all. So this is always going to be false at the moment. And I'm actually going to do this in a little bit different way. We're 3/4 of the way through 116 and all of 115 or AP, wherever you're coming from. You're getting up there in your computer science, your programming skills. So I think I can do this very little trick. It's not barely even a trick, but you can definitely handle this at this point. What I'm going to do is, by the way, if you've ever heard this, code never lies, comments sometimes lie. You may not have heard that yet in your careers. But right here, I'm going to put a not here, and my comment lies right now. This is exactly the opposite of what's happening. We haven't seen the country before. Comments often lie. If you notice a stark lack of comments in my code, I subscribe to the self-commenting code philosophy. I always want my code to be explicit. If my code's explicit, I don't need comments. And if you have comments and you change the code, the comments might say the exact wrong thing and be very misleading and very counterproductive. So it's a philosophy. You can talk about it offline if you want. But are we allowed to assume our title will only contain letters? Oh, goodness, no. No, the title won't always only contain letters. I'm not sure how that assumption would help you, though, either. Like when you're comparing two titles, hit it with the dot equals and compare if two titles are the same. If it's a string, like strings can contain numbers. Numbers are valid characters in a string, if that's what you're getting at. So if a string contains numbers, that's perfectly fine. I can have a string. Oh my goodness. I can have a string that contains numbers. That's perfectly fine. Not here because I didn't put it in a variable. But this is perfectly fine to have. Yeah, any string can contain numbers. The title, the Spotify IDs, they're, with high probability, every one of them is going to contain at least one number. And that's perfectly fine to have in a string. Now, these strings are only numbers. Strings can be numbers. Yeah.
I was asking about that because containing keys would mess up on that.
No. No, contains key is fine if the string contains numbers. Works just the same.
Oh, what about dot equals ignore the as is that?
Oh, that's more complex than I want. With ignoring case, did you say?
Yeah, ignoring case.
Yeah, it's fine. Like numbers don't have any case. Same with special characters. They just any one of the 26 letters, the case will be ignored. All the other characters have to be exactly equal. There's no lowercase number, uppercase number. That method doesn't break on that fact, though. All right, so what I'm going to do instead of, you could come up, I'm sure you could all handle this situation and come up with some solution to it. They all might look slightly different and everything. I want to show what I like as probably the cleanest way, or my most preferred way, I guess, is called lazy initialization. So we're going to lazily initialize the array list for a country. So I'm going to say, if I have not seen this country before, so if this country is not a key in this hash map, that means I've never seen it before, because as soon as I see it, which is right now, this is the first time I'm seeing it, I'm going to add it into the hash map. For that, I'm going to do countries.put. The country is the key, and then new array list as in empty array list. And right here, you might be tempted to add that city right here, because that's what we're about to do. We have to add that city into this array list, but I'm not going to. I'm just going to initialize. I'm only initializing the country to an empty array list, and that's it. And I'm doing this at the last possible moment. That's the lazy part of this. I'm doing it at the last possible moment. As soon as I see a city from a country, and I'm seeing that country for the first time, that's when I initialize the array list, and not a moment sooner. I'm not going through all of my data, figuring out what countries I need, initializing all the array lists, and then going through all the data again. I'm just lazily doing it at the last possible moment. And then, whether I initialize this country or not, whether it's the first time I've seen this country or the millionth time I've seen this country, I don't care. no matter what, I'm going to add this city into its array list. So I might be adding to an empty array list. I might be adding to an array list of size 909. I shouldn't do that example. I don't want to do all the nines. Millionth element, doesn't matter. I'm going to get the array list for this country, and I'm going to add that city. I don't care if that array list is empty. I don't care if it has 1 million elements in it. Whether I initialized it just now or not, whether this just happened or not, I don't care. I just know that the array list for this country needs to get this city added to it. In this line, we're taking advantage of our understanding of references. Hopefully you're all getting very familiar with references. By this point in the semester, you really need to be, or else you wouldn't have, I don't know. But we're going to get the value at this key. The value is a reference to an array list of cities, and then I'm going to call add on that array list. So add is being called on the array list for this country, and then being added, the city's being added to that array list, and this is all happening by reference. So the only time I actually add a key value pair to the hash map is this line right here when I'm adding an empty array list. It's the only time I'm adding things to this hash map. Hash map stores strings to references of to array lists, and then I'm going to that array list by reference and then actually adding the data to the array list in this line. No. So you don't need else. Whenever you have a conditional, else is optional. If I had something that I wanted to do, if it's not the first time I've seen the city, then I would, but it's not. Whether it's the first time I've seen the city or the millionth time, I'm always doing this, no matter what. But if it is the first time exactly, I'm going to do my lazy initialization to an empty array list. Yeah. Yes, but there's a better way that I'll share with you. I'm glad you said this because I almost forgot. I recommend for the songs, nothing about this song method mentions a hash map at all, but I do recommend still building a hash map. This is my expected solution, the way you don't have to do it this way. If you find a way that works, go for it. But this is the way that I'm advertising and kind of showing you the light of, is create a hash map. It's going to map song IDs or any unique identifier with songs. The song IDs are going to be unique. Spotify's guaranteeing that for us. And then map that to your song objects. And then do the same thing we're doing here. Is it the first time I've seen the song ID? And then that contains key based on strings, which has an equals method for us. Is it the first time I've seen this ID? If it is, create a new song object. If it's not the first time I've seen this key, or if you set up the same exact way, regardless, add this rating to the existing song. And then you have one extra step to do at the end of the loop after going through the whole file. You'll have to go through all the values in that hash map and stuff all those songs in an array list, because the method asks you to return an array list, not a hash map. So you have to get all those values in an array list and then return the array list. Song ID, always unique. Yep. You can assume that. Yeah, that's why the ID's there. Well, also so we can get the Spotify links. But that's why an ID needs to exist.
It's better because it checks, it hashes the thing and it goes to the reference, checks if it's smaller one. So smaller, iterating over the whole.
What was that? I missed some of that.
Like instead of iterating over the whole list, you're using a hash map because it will just check after hashing the thing. Go to this reference file and check if it's smaller or not.
Why are you working with lists at all? So we have the list of ratings, but we already have the add rating method. You already handled all that. You just call add rating. Right? Is that what you're asking?
I'm asking.
Other than that, you don't have to work with the list.
I'm asking instead of saying contains key, so in order to check if something contains it, use a different data structure instead of using a hash map. Use something else. That would cause an issue because you would have to iterate over the whole thing.
Yeah. Not necessarily an issue, but it'd be slow.
Yes.
Yeah. And if I didn't give this hint, if I didn't do this in lecture, that would be my expected solution. You would create your array list of songs, and then each time you read a line, go through the entire array list and check, does this song have this ID? Does this song have this ID? And then if you find a song with the ID, then add the rating to that song. But there are better ways. This is much more efficient. We're not really concerned about efficiency in this class, but I think this is more code efficient too. I think it's easier on the brain, which is a nice thing to have as well. And this is it. This is the method. That's it. Nothing else to do. We already have our return statement. Returning countries. Countries got all the data in just 4 lines using this lazy initialization technique. And then it took more lines just to parse the data. Of course, we could put these values, we could stuff these in the constructor to, if we're really concerned about lines. I'm not, but that's it. That's our method. So let's test this thing. And this is, we'll do debugger on Friday, and I'll have a similar example or the same example or something, but we'll have a whole bunch of bugs in this thing. This one is intended to be correct, but I did write one intentional bug. There is one bug in here that's going to break. So we'll write some tests, we'll see this fail, and figure out what that bug is. Yep.
Yeah, I remember how with the song objects we wrote old code where there was comparators. Are we allowed to use that in our test file? Kind of like if I wanted to use the song Bayesian rating or the other one, the title comparator, am I allowed to use that in the test file?
Yes. Yeah. I'm trying to think of how it would help you. Yeah, I could see how that would help you. Because you're trying to take care of the order, right? Yeah. Yeah, you can use those. Loud. All right, so let's write some tests. Let's start testing these things. How do we test a method that takes a file? First, I want to talk about helper methods because I didn't feel like going through all this during lecture. We did this last week where we're testing data structures, so I don't want to dwell too long on it. But let's just go through this. We have the task of comparing 2 hash maps, and a lot of you will still do the thing, manually going through the data and checking for each value existing. Like if it's an array list, you'd say, give me the value at index 0, is it what I expect? Give me the value at index 1, is it what I expect? Linked list, give me the value, is it what I expect? Give me .next.get value, is it what I expect? And that's fine. If that's the way you want to do it, go for it. But this is the way I like to do it, set up my helper methods that's going to take my expected and actual data structure and then go through all of the values, no matter how many of them there are. And then in my tests, I'm going to create my expected data structure, give that to this method, give my actual that I got from calling the method I'm testing, and then let my helper method do all the work from there. Again, I always want it to be as easy as possible to create new test cases. I'm going to copy and paste my code, get my new inputs, my new expected output, and then give my helper method all the work to do. It's a pain to write new test cases, which any of you who do this know this already. It's a pain to write new test cases when you're manually writing all of the code for every single test case without any helper methods. If that's the way you want to go through the whole semester, I ain't going to stop you, but I am going to show you the light eventually in your career. Hopefully you write methods like this. But anyway, I have to compare 2 hash maps. I can check for null. I'm not too concerned with null with a hash map, but for thoroughness, I could add a null check here. With linked lists and trees, I would absolutely 100% have my null checks because we use null in those data structures. I'm not too concerned here with hash map, but for thoroughness, it wouldn't hurt to add it. But whether we have a null check or not, the next thing we want to check is the size. Are these 2 data structures the right size? If my actual isn't even the same size as my expected, we're done. That's it. There's no possible way it's right. Get rid of it right away. If they are the same size, I'm going to iterate through all the keys that I expect and make sure that my actual contains that key. So if this passes, if this were the only check we're doing, we're making sure that the actual has all of the keys that we expect. Since keys in a hash map have to be unique, we can't have duplicate keys in a hash map. The size is the same, and the actual contains every key from the expected. I know that there's a one-to-one relationship between the keys. the expected has, the actual has exactly all of the keys that we expect, no more, no less. So we got that check for all the keys. And then for each key after that, we're going to grab the array list of cities for that country and make sure that array list contains all the cities that we expect. And I do have an assumption here. Check the sizes first. We do have an assumption here that the values in the array list will be in the same order as they appear in the file. So if I were writing this as a homework task, I would have to specify that. I'd have to say the cities in each array list are in the order that they appear in the file, and you can assume that that order is correct. Same is true for the songs, for the song ratings. Those linked lists will have the ratings in the order in which they appear in the file, so you can assume the order of a linked list. For the array list, that's not true. The array list can be in any order, and I expect you to go through the array list handling any order like we did last week. For the linked list, that's a bit more of a pain. It just gets tedious and kind of torturous, so I don't make you do that for a linked list. Linked list, you can assume the order. And here we are assuming the order of the cities in the array list. So I'm going by index, getting the index at index I for all of the indices, and then calling another helper method that compares two cities and just goes through each value and makes sure that they're the same. Making sure that I'm comparing doubles with some epsilon. Okay, so that's my helper method. My task writing tests is to generate my expected output and then toss it off to my helper method. My helper method do all the work after that. And finally, we're at the point where we can test this thing. So our method, load countries, is a static method. So we're going to call it through the class itself. The class is country examples, or countries example. Countries example dot load countries, some file name. That's going to give me a hash map of string to array list of city. And that's my actual. Copy and paste this because I don't feel like typing it again. My expected is going to be some new hash map that I'm going to populate with what I expect. I'm going to call my helper method expected, get the right order here, expected actual. So this is what I want to do. I'm going to put some values in here, and I need to figure out what I'm going to use for my test case. So I need some file name here that I'm going to use for testing. But what should this file name be? The obvious answer is cities.csv. But cities.csv, as we said, has tens of thousands of lines of data. I'm not creating my expected data structure with all of this data to make sure I have everything I want. If I use this file as a test file, I'm going to end up using shortcuts. I'm going to check just the size of the data structure, make sure it has enough countries in it. And even that's difficult to do. I have to go through this and count all the unique country codes. And I'm probably going to miss one because there's some countries in here with only one city. I'm probably going to scroll right by it and not even notice it. So I'm tempted to write code that's going to do that for me. And now I'm in a situation where I have my code testing my code. I don't want that. So I would be more tempted to go to a spreadsheet. I would take all this data, open it in a spreadsheet, and then write some Excel magic or Google Sheets magic, I guess, and have it count the number of unique country codes, make sure I don't count the header line as a country, and then process that, get my expected, and then put it in my test cases. And that's going to be much less error prone. We don't like having errors in tests themselves because they're hard bugs to find. And we especially don't want the errors where we make the same mistake in our test case as we do in our code. And if you have code generating your test cases, you're likely to have those kind of bugs. Those are the scariest bugs, where your test cases are saying everything's great, but you have a bug that you have no idea about. But your bug is in your test cases and in your code because you made the same mistake both times because you used your code to generate your test cases. And in 1.16, it's not too bad. It still sucks, but you submit to Autolab, and Autolab says your code sucks. And then you know you have something to fix. Outside of a course, these are scary bugs because everything looks great on your end. Then you ship your software, and your users find the bug. And that's scary. That sucks. And it happens a lot. Some of you have even find bugs in my graders, or I push it out with bugs. It sucks every time. I get mad at myself every time. Not mad, but I don't know, maybe mad whenever I have that happen. But it's a hard thing to avoid. It's just tough. So we do whatever we can to avoid it. In this situation, I would use a spreadsheet and then use that spreadsheet calculations to test my code. So I'm generating my expected value over here in a spreadsheet and then getting my code that I'm actually testing over here, which is Java code. So it's less likely that I'm going to make the same mistake both places. I might make two mistakes and make mistakes in both places, but hopefully it's not the same mistake. So I at least see a test case that's failing that gives me an indication that something's wrong and there's something I have to fix. And I can look at, is it my test case or my code or both? But if I make the same mistake both times, it's less likely if I make the same mistake in Excel, probably not going to make the same exact mistake in Java in the same exact way and come up with the same exact incorrect thing. It's less likely. Still possible. I shouldn't say likely, but still possible, but less likely. And that's all we can do is mitigate the risks as much as we can and build in all kinds of redundant checks. And some things still get through. Sometimes bugs still get through. But we're going to do what we can. But we're going to not use this test file because we're going to be tempted to take shortcuts in our testing if we're using this file. I'm not building the entire expected data structure. So what we do when we're testing files is come up with test files with much, much, much less data. I have as little data as I possibly can get here. One city. Cities test 1. And this is what you're expected to do on task 6. Generate your test files. Put them in a directory named data in the root of your project. And then use those files for your test files. So I have one with just one single line here. And let's write this as a test case. I like having a comment with my data. And this is cities test 1. And your paths for your file names are always relative to the root of your project, at least the way IntelliJ sets things up and the way Autolab is set up. It's relative to the root directory of your project. So our files, all of your files in your tests should start with data /. You start in your root, and then you go into the data directory, and then your file name. citiestest1.csv. Don't fall into the mistake of putting your tests in the same directory as your test file. It's a common assumption. It makes sense, really. Your file is right here. So if I just put the file name, I should have to put that file in the same directory as the code that's running that's reading that file. It's a reasonable assumption, but it is false in this case. The file paths are always relative to the root of your project, regardless of where the code is executing from, where the code is actually written. Why must the arrays be allowed to be out of order? Oh, yeah, for test 6, because I want you having practice with that. That's going to be a situation in the real world. You need practice with that. If you go out there in the real world and never have practice with that, I don't know if I've really done my job of showing you how testing works, how to test with test methods that return data structures. If the order doesn't matter, it's going to be the case a lot of times in the real world. There's a lot of data you work with that the order doesn't matter. Writing test cases for that, you have to handle that. You just have to handle that situation. It's a fact of life. It's just part of it. Fact of programming, at least. So now I'm going to build my expected new array list, arrays.asList, new city, and then I'm going to cut and paste this. Oh, I can't quite cut and paste this, can I? I mean, I'm gonna. But I did this in a weird order. Name, region, country. Name, region, country. Name, region, country, new location. Okay, and there's my expected, and we can pretty this up a little bit here. It's fine. So this is what we expect. A hash map with one key, with an array list with one value. This is my barometer test. If I'm failing this test, I know everything's completely messed up. So I want to be able to pass this one. We run it, trying to build our confidence, and we get it crushed. This is our bug that we have not addressed. We actually get an error, number format exception. This code is broken. Oh, jeez. I just ran this in the last lecture. I know it happens because I pulled the code. I'm getting this like every live lecture. It's because I keep changing this from between Java 19 and 20. I just need to get rid of every reference to 19. Number format exception. There we go. That's what we expected. And I'll say most of the debugger talk for Friday, but we can run the debugger quickly here, figure out what's going on, figure out what our bug is. When we go through the lines of the city, oops, I got into the array list constructor. I'm going to step out of that. The first line is country, city, region, population, latitude, longitude. We got the header line here. Step over the array list constructor this time. And as soon as we get to integer.parseInt splits of 3, splits of 3 is the literal string population. That's not parsing, isn't it? We have to find a way to ignore this header line. There are a lot of different ways to do this. Lots of different ways of addressing it. I'm going to do it probably the dumbest way, is if line equal, whoa, that would have been a bad one. After I harp on never use equal for strings so often. No way. If the line equals the header line, and just to show you an extra thing, I think we're at the point where I can start showing more tips and tricks. I'm going to use the